Okay, this is going to be your parametric equation review. For the first part, and you'll have something like this on your exam, you'll need to go through and fill in a chart based on the two parametric equations that you're given, and then you would need to graph each one. Now, there's been some question about why you have this here. That is just telling you what you would be substituting in. That's your range of numbers. And that range of numbers is already laid out for you here. And I would be giving you these numbers so that a little bit of consistency in what we're looking at. Now, if you go through and start plugging in these values, for the first one, when t is -2, when you plug that in here, -2 squared is +4. 4 plus 1 is 5. And so you have the square root of 5. Or in place of square root of 5, remember that the square root of 5 is approximately 2.2. So that might be a better number to record since we are going through and graphing those. So I'm going to change these radicals over to decimals. And then our y value, when I plug in -2, is going to be a +4. Again, we would have 2 minus a -2, which is plus a positive. And so whenever we plot this, remember we would be graphing the point square root of 5, 4, or 2.2, 4. So if I do that, let's see, I would go over 2.2 and then up 1, 2, 3, and 4. So there's going to be my first point. And we would continue on through here, and let's see, the next one, square root of 2, or 1.4, and let's see, 3. And we would plot 1.4 over 1.4, and then up 1, 2, 3. And don't forget, we are connecting those and drawing our arrows as we go. If we plug in 0, we have 1 and 2. And so over 1 up to, here's my other point, and again continuing that arrow. And let's see, our next point would be 1.4, 1, 1.4, and then 1. So it looks like we're starting to have a bit of a turn here. Please, no sharp edges here. Try to make your turn. And let's see, when we have 2, again we would have square root of 5, which is about 2.2. And then we have 2.2, 0. So over 2.2 and 0. And again, connecting those. Make sure you have your arrows. And let's see, the next one, square root of 10, so about 3.2. And let's see, 3.2 and -1. And let's see, I'm going to continue out. Square root of 17, about 4.1, -2. Plugging in 5, square root of 26 is about 5.1, -3. And then the last one, 6.1 and -4. And we can finish plotting our points. We have 3.2, so over 1, 2, 3.2, and down 1. And again, continuing on with my arrows. 4.1 and -2. And then let's see, 5.1 and -3. So it almost looks like we've got some kind of slope going on here. And let's see, 6.1, -4. And so again, connecting these. And that should be about what you see graphed here. Some students were wondering about typing this in the calculator and then going and looking at your table feature, you are more than welcome to do that. There's nothing wrong with it. You do want to pay attention again to your table of values that you're given and make sure your t is changed to be, instead of between 0 and 2 pi, make it between -2 and 6. And you should be able to access the table feature on your calculators for that. Okay. Now for these next ones, we will be eliminating a parameter. So we need to rearrange these equations, and normally it's a great idea to rearrange the x equals equation starting here and then plug into what you're given for y. So if we choose to do that, let's see what we end up with. So our first equation, we have x equals t minus 2. So what we can do is really multiply both sides by t minus 2. And so I would have x times t minus 2. And that would be equal to 1. And then here I would divide both sides by x. And so I have t minus 2 is equal to 1 over x. And then we do want to add 2 over to the other side. So I have 1 over x plus 2. And now what we're going to do is take this t value and we're going to go all the way back to y and plug it into this y equation. And when I do that, I have y equals 4 times, and I'm going to plug in what I solved for t here. So 1 over x plus 2, and then plus 5 to finish out that equation. So notice this t value changed to what I solved for it, and this would be your final answer here. There's no need to do any more to it, so just leave it like it is. Okay, so trying for number 3, again, we'll be doing the same idea. I'm taking this top equation and rearranging it. So I would think we would probably need to add t over. So I have x plus t equals 6. And then I'm going to subtract x over to the other side. So I have t equals 6 minus x. And then we're going to take this value that we're given, that we found, and we're going to sub it in. So I have y equals the square root of 3 times t, but in place of t, I'm going to put 6 minus x, and then minus 4. And again, don't do anything else to this equation. Leave it just like it is. All right, moving on to this other step. Same idea again, and I'm going to go through and I'm going to rearrange this top equation. And so I'm going to subtract 4 over. So I have x minus 4 equals 1/2 t. And I do need to divide both sides by 1/2. But remember, dividing by a fraction is the same as multiplying by its reciprocal. So I'm going to multiply this side over here by 2 over 1, or just 2. And notice those 2's are going to cancel. So I have 2 times x minus 4, and that is equal to t. Now I'm going to take that value and go sub in. And so I have y equals, and notice all of this t value is cubed. So I'm going to do parentheses 2 times x minus 4, or you can do 2x minus 8, and then that's all cubed. So, and again, please leave that just like it is. No need to try to simplify it up. That right there should be fine. Okay, moving on to the next round of problems. This is where we're still trying to eliminate a parameter. But the problem with this is we have t as our angle, and so we can't really get t by itself, so to speak. So we're going to have to use our trig equation, sine squared, and I'm going to write this again, and you should be using this one. It's going to be sine squared t plus cosine squared t, and that's equal to 1. So our goal for these problems would be to get sine and cosine by itself on one side. And so for the top one, I'm going to divide both sides by 3. And when I do that, I have x over 3 equals cosine t. And I'm going to do the same thing for this equation down here. I'm going to have y over 3 equals sine t. And now once I have those simplified as far as I can, then I would go through and I'm going to square both sides so that I generate a value for cosine squared and sine squared that I can substitute into my trigonometric identity. So once I do that, I have x squared over 9. Don't forget to square the bottom. Everybody does. Try not to forget that. And that is equal to cosine squared t. And then, same is true over here. You have y squared over 9. And again, don't forget to square that denominator. That's equal to sine squared t. Now we have specific values for sine squared and cosine squared, so we should be able to substitute those values into our trigonometric identity. So in place of sine squared, I'm putting y squared over 9 plus cosine squared, so I'm going to put x squared over 9. And all of that's equal to 1. And it is perfectly okay to leave it just like that. Okay, moving on to the next problem. I know a lot of people would be confused with seeing this 2t here, but again, as long as these angles are the same, that squaring process and that trig identity is still going to work. So we would start this out the same way. I would have x over 4 equals sine of 2 times t. And then I would also have the same over here for y over 2 is equal to cosine 2t. And now we would square both sides. So I would have x squared over 16 equals sine squared 2 times t. And then I have y squared over 4 equals cosine squared 2 times t. And now we're ready to sub into our identity. So I would have x squared over 16 plus y squared over 4. And that is all equal to 1. And again, please leave it just like that. No need to do any more simplifying. Okay, and now number 7 could be a little bit tricky, so be careful with it. Unless we get in the habit of a pattern, and so we're not really thinking about the problem itself. And so let's see on this one why I'm saying it might be a little tricky. Well, we got used to having to divide a number over. There's nothing to divide over in this side. So we're really ready just to square both sides on that problem. So x squared equals cosine squared t. Now for the y part, notice we already have this squared. So I just need to divide the 2 over. And so I have y over 2 equals sine squared t. So now that's, again, we have the same identity. We still have sine squared and cosine squared, but we didn't have to do as much work as we did on the previous two. So don't let that mess you up. So when we put this together, we have x squared plus y over 2, and all of that is equal to 1. Now that answer doesn't look like your previous answers, and don't let that fool you. Everything is still okay with this problem, and we've done everything we possibly can do to it. Okay, now these next problems are going to be calculator problems, And so what we're going to do here is talk about the steps that we would follow. And I have very specific screenshots of each step and how to type in a parametric. If you don't remember, that is on your notes, and you should have written it in on your note-taking guide. All right, so for number 8, they've already given you the parametrics, and on the test, I will give you a couple of problems that should already have the parametric written out for you. So what you would need to do is put that in your calculators, and so you need to look at the graph of these equations. So make sure you do that. And then, oh, that you didn't write, there we go. And then I want you to use your trace feature, which is under the menu. And then we went to trace. And then under trace, it was option 1. And then you were able to trace out this information. So for A, how high is the ball after 1 second? You should have seen the ball be 48. And what was did it give us some units on this? It didn't. I'm going to go ahead and just say feet. So after 1 second, you should be at 48 feet. Notice that you would look at the y coordinate for that. Okay. Now, you certainly are welcome to plug in 1 into this equation here. And that's really what's going on there. Now, part B, when does the ball hit the ground? So notice it's saying when. It doesn't say where exactly. It just says when. And so the ball, if you look at your graph, it should look something like this. And so you need to look at the time aspect whenever the ball is over there. And your t-value, if you have this graph correctly, you should have a value of t equals 4 seconds. And then if you're talking about here where the ball is at its highest point, so again, you should have a sketch something like this. The highest point would be up here where the vertex should be. And your highest point, that's going to occur when t equals 2. So here, when is the ball at its highest point? At t equals 2. That should be at its highest point, or 2 seconds. And what is the highest point of the ball? The highest point of the ball should be 64 feet. So do pay attention to the wording, because the wording is going to tell you which coordinate to look at. You will need to either look at x or y or your t value. Okay, and this one is going to require us to go in and fill in our formulas. Now, I will be giving you the formula, so don't be worrying about having to memorize that formula. Now, the first formula we were given, we were told that we had x equals, and we have our initial velocity times our time times cosine of an angle that we're given. And you should be given that information each time. And then our y part, or the y parametric, would be our height times the initial velocity, or plus, initial velocity times time times sine of the given angle, and then minus 16t squared. Now, I'm writing it like this with the dots because in the calculator, please make sure you include that multiplication, because the inspires will get messed up if you don't. They won't graph it. All right, so let's look at the information we're given. So we have a ball that's hit 3 feet off the ground, so I know my height is 3 feet off the ground with an initial angle of 40 degrees, so I know theta is 40 degrees, and make sure those calculators are set in degrees. with an initial velocity, so v sub 0, of 115 feet per second. Okay, and that's a C. Now, we're asked when will the ball clear an 8-foot fence that is 370 feet from home plate? If so, by how much? If not, then where does the ball land or hit? So the first thing you would need to do would be to build your two equations. So we need to go and fill in our given information. So we have x equals 115, our initial velocity times time, and time's going to stay as our variable, times cosine of 40. And then our y is going to be our height, which was 3, plus, and let's see, our initial velocity, 115, times our time, times sine of, what was our angle again, 40, and then minus 16t squared. Now, when you graph this, you might have to do a zoom fit, and that zoom fit will help you see the entire graph, because if you graph this and you just have a straight line going outward, you know that cannot possibly be the path of a ball. So you do need to do a zoom fit here, and that's going to be I think option A after you do window zoom. And so let's see if once you look at your graph, you should be able to answer this question. Will the ball clear an 8-foot fence that is 370 feet from home plate? So the answer to this would be yes. And the reason why is because when the ball is at 370 feet, let's see, where did it end up at? At 370 feet, the ball is how far off the ground? 31.2 feet off the ground. So wow, that's pretty good. So the ball clears the fence by 23. So I'm going to do this and say the ball clears the fence. And you need to go in and look. Let's see, clears the fence by 23.2 feet. So there's our answer. Hey, with this problem, you do need to sketch the graph, and most of these graphs hopefully we're seeing are about the same. When we put the information in the calculator, we should be seeing something like this each time. And so you do a rough sketch. It doesn't have to be perfect, but just an idea of the path that the ball is traveling. And then for part B, how far downfield did the ball first hit the field? Well, if you've got your equations correct and you type in and you look all the way down here, the very end, the ball does travel a little over 209 feet. Somewhere close to 209.14, somewhere around in there. Then that's how far down the field the ball traveled. Okay, and then for part C, the maximum height that the ball should get is right around 77.6 feet. And again, you can collect all that information from the graph in your calculator. So do make sure you're able to graph that. Now the two equations that you would need to type in here, you have x equals, and you need the initial velocity, so 85 feet per second, times time, times cosine of our angle, which is 56 degrees. And again, make sure you're in degrees. And then our y, well, what about the height? We were not told a height. And I would think that, I know it says punter, but I would think that the ball is on the ground instead of the person holding it. I would almost, instead of punter, I would say that it was a kick, or like just kicking the ball. So anyway, the height would be 0 here, and so you don't have to include it. And so we would have 0 plus, and then we have our initial velocity times time times sine of our given angle. And then don't forget the minus 16t squared. And so these two should be your parametrics that you're typing in the calculator. And I hope this helps, and if y'all have any questions, please post them or ask me in class.